Alright, and welcome to Solving Quadratics Flowchart. Oh, let me put the little S there. Solving Quadratics Flowchart. Now in this one, in the previous few videos, I've been teaching y'all how to solve different quadratics, but here we're going to be exploring why you should use a particular method. And I've created this nice little flowchart over here to the right. So here's what we'll do. We'll ask ourselves first, is a quadratic in vertex form? If not, we then ask, does A equal 1? Then we ask, okay, well if A doesn't equal 1, that's what this means, A doesn't equal 1, is A the GCF? And of course, if that's not true, well we go on down to where A does not equal 1 and A is not the GCF. And so we're going to go through 4 examples and I'll show you how to solve each one of these using, of course, the different methods that I've taught y'all. So guys, this has to be a complete video and I need y'all to watch all 5 examples. Okay, so let's start with example number 1. F of x equals 2 parentheses x minus 5 close parentheses squared minus 200. And y'all are going to notice something. This is actually in the form of f of x is equal to a parentheses x minus h squared plus k. So this is in fact in vertex form. Alright, so what do? Well, we know that for every quadratic, we always set f of x equals 0. And from here, we are just going to solve for x. So whenever it's in vertex form, we're simply going to solve. We know the first thing we always get rid of is our addition or subtraction. In this case, since it's minus 200, we will add 200 to both sides. And 0 plus 200 is simply 200, is equal to 2 parentheses x minus 5 squared. Now from here, we know the next thing we always want to get rid of is our multiplication. So we will divide both sides by 2. 200 divided by 2 will of course give us 100, which is then equal to x minus 5 squared. And notice guys, in order to get rid of a square, we always do the opposite. Well, the inverse operation of a square is a square root. And you'll notice something here. The square root of 100 is 10, but that's actually not totally true. Remember, when we take square roots of numbers, there's actually a positive and a negative solution. So plus or minus 10 is equal to x minus 5 because the square root and the square cancel each other out. Now from here, remember we actually have 2 solutions. Okay, let me just kind of separate this off. We have positive 10 is equal to x minus 5, and we also have negative 10 is equal to x minus 5. In both cases, to get rid of a minus 5, we will add 5 to both sides, and 10 plus 5 is 15, which is equal to x. Over here, negative 10 equals x minus 5. We'll add 5 to both sides. We'll add 5 to both sides. And negative 10 plus 5 is, of course, negative 5, is equal to x. So notice, we would say this, just using a different color so it really pops out. We would say x equals negative 5, comma, 15. And remember, those are the 2 solutions, the 2 roots, the 2 x-intercepts, the 2 zeros. That's where we cross the x-axis. Okay, let's move on. Okay, here in example 2, I have a 2a and a 2b. So notice, we go over to our quadratic flowchart over here, and our first question is, are these in vertex form? Well, they're not really, because we know that they're both in the form of, let's see, ax squared plus bx plus c. And this one, of course, is also in the form of ax squared plus bx plus c. So they're not in vertex form. However, check it out. We do see that a equals 1. See, our a term here is a 1. Our a term here is a 1. Another way you can think of it is if there's no visible coefficient in front of x squared, a has to equal 1. So how do we solve something like this? Well, we are going to use simple factoring. Alright, I'll just write simple factor for shorthand. Now, remember, we always want to set f of x equal to 0, and so we have 0 is equal to x squared plus 8x plus 12. And we know that we can actually rewrite this as 0 equals 2 sets of parentheses, where x squared breaks down into x and x. Remember, we can only do that when our a value equals 1. Now here is the case where we want to take our c term, 12, and we want to break it down into 2 numbers that multiply to be 12 but add up to be 8. And remember, my factors are 1 and 12. They are 2 and 6. And if I had room, I'd write 3 and 4. Well, 1 plus 12 is equal to 13. 2 plus 6 is equal to 8. And since we're looking for the two numbers that add up to be this middle term of 8, we found them. Since there's a positive 2 and a positive 6, I'll write x plus 2 and x plus 6. Now from here, it's fairly easy to find the solution. We simply say x equals, and we want to know what value of x will make a positive 2 equal to 0. Well, the opposite of positive 2 is clearly negative 2, comma. What value of x makes a positive 6 equal to 0? Well, the opposite of positive 6 is clearly negative 6. And so we have our two solutions. The solutions to f of x equals x squared plus 8x plus 12 are negative 2 and negative 6. Okay, let's go on to our next one. Now, example 2b, we see it's clearly the a term is equal to 1, and we're still going to use simple factoring. But there's another way to think of this one. We can write 0 equals 2 sets of parentheses. We know x squared breaks down into x and x. And if you would like, you can ask yourself, well, what two numbers multiply to be negative 49 but add up to be 0? Because see how there's no x term here in the middle? So that means b of x isn't there. That's telling us b is equal to 0. Or, if you recognize it's a difference of squares, you can simply take the square root of 49. Well, the square root of 49 is 7. So 7 times 7 is 49. But how do you make 7 and 7 equal 0? Well, you make one positive and you make the other negative. And at this point, it should be pretty simple to figure out the solutions. We know that right here, the opposite of a positive 7 is a negative 7, comma, and here the opposite of a negative 7 is a positive 7. So remember, this was our special case, a difference of squares. Alright, well let's move on. Okay, here we have example 3. F of x equals 4x squared minus 12x minus 40. Well, firstly, we note that this is in the form of ax squared plus bx plus c. So we know it's definitely still not in vertex form. We also know that our a term is 4, so we know that a does not equal 1, so we can't use that. So here we are with this question, or this scenario, where a does not equal 1. So our first step is to ask, is a greatest common factor? And what does that mean? That means, can I factor out a 4 from each one of these numbers? And I would hope that you would say yes, because f of x is equal to, and if I factor out 4, that means I'm going to divide literally every single one of these by 4, and I bring that 4 out in front. Well, if I factor out a 4, pull it out from each one of these terms, what is 4 divided by 4? Well, that will just leave us x squared. What is negative 12 divided by x? Well, that will leave us negative 3x. And what is negative 40 divided by 4? Well, that's negative 10. Now from here, you'll actually notice something interesting. We actually now in parentheses have an a term that is equal to 1, and so we can go back to step 2 and try our simple factoring. Okay, and all the while we'll keep that 4 out in front. So I'll keep my 4 out in front, and then I'll break this down into two sets of parentheses, where I know x squared can now be broken up into x and x. And here, remember, we want to break down negative 10 so that its two factors will add up to be negative 3. Okay, well, we know negative 10 can break down into 1 and 10 and 2 and 5, and those are really our only two options. Now also notice, when this is negative, we need a positive and a negative. Okay, and since our b term is negative, that means the larger number had to be negative. Okay, so if I combine these, what do I get? 1 minus 10 is negative 9, and 2 minus 5 is negative 3. Well, wait a second. We're looking for a b term of negative 3. We have it right here. Our two numbers that we're going to do are positive 2 and negative 5. Now from here, guys, it should be fairly simple to figure out what your factors are. Remember, we're always going to take f of x and set it equal to 0 to solve for quadratics. And here, the x value that is the opposite of positive 2 will be negative 2. Here, the x value that's the opposite of negative 5 will be positive 5. And those are your x-intercepts, your solutions, your zeros, your roots to the quadratic. That is where we are crossing the x-axis. All right, let's move on to example number 4. Okay, here's example 4, and we have g of x is equal to 15x squared minus 7x minus 2. Well, firstly, we know it's in the form of ax squared. Let me switch over to orange. Ax squared plus bx plus c. So it's definitely not in vertex form. We know that our a value is 15, so a does definitely not equal 1. And next we ask ourselves, is 15, or is the a value the GCF? Meaning, can 15, negative 7, and negative 2 all be divided by 15? Well, guys, clearly negative 7 and negative 2 cannot be divided by negative 15. So this is the situation where a does not equal to 1, and it is not a GCF. So here we will use factoring by grouping. And notice I kind of wrote it real weird because my pause button is over here in the bottom right hand corner, and I didn't want to pause the video. But yeah, guys, when a is not equal to 1 and a is not the GCF, we want to attempt to use factoring by grouping. Okay, so what in the world are we going to do here? Well, remember, our step 1 is to always do a times c, or in this case 15 times negative 2, which will give us negative 30. Remember, our step 2 is we want to break this down into two numbers that multiply to be negative 30 but add up to be our b term, or in this case, negative 7. Now, what are the factors of negative 30? There's 1 and 30, there's 2 and 15, there's 3 and 10, and of course there's 5 and 6. We also see that our b term is negative. That means we can make all of the larger numbers negative. Because there's more negatives than positives, we have negatives left over. 7 to be exact. Well, guys, what's 1 minus 30? That's negative 29. That's not what we're looking for. What's 2 minus 15? That's negative 13. It's not what we're looking for. What's 3 minus 10? Well, that's negative 7. And that is exactly what we are looking for. Now, I had a lot of students who are still a little bit confused on this. What are we saying here? We're saying if we take g of x and we take the first term and the last term, so 15x squared, and I'll leave a big space and I'll write minus 2 over here. And if I break up, I'll do this in this nice purple, if I break up negative 7x, I can create two different sets of factors. Now I'm breaking up negative 7x into a positive 3 and a negative 2. And the question becomes, what goes where? Well, since 3 and 15 have a common factor, I'll put my positive 3x with my 15, and since my negative 10 and negative 2 have a common factor, I'll write minus 10x right there. And then this allows me to break these up into two separate groups. Now from here, since we're getting pretty close to solving, well, we'll still keep g of x as is. We now want to factor out one common term from each of these. In fact, now that I have this, let's give ourselves a little bit more space. Okay. We know that 15 and 3 can both factor out a 3, so that means we'll divide them both by 3. And this has two x's, this has one x, they can both give up an x. So I wrote my parentheses just a little bit prematurely, we'll factor out a 3x. Now, in purple, let's leave our leftovers. 15 divided by 3 is 5, and x squared divided by x is simply x. Here, positive 3x divided by 3x is plus 1. Okay. Now when I look right here, we have a negative 10x minus 2. Well, remember guys, if your x term is negative, we must divide out by a negative. And 10 and 2 can both be divided by 2. So, kind of keeping my colors consistent here, I will factor out this negative 2 right there. And what are my leftovers? Well, a negative divided by a negative is a positive, and 10 divided by 2 is 5x. And what about negative 2 divided by negative 2? Well, that will be positive 1. And what do we see here? Guys, we're going to do two things. One, to solve this, we always set g of x equal to 0, or f of x, or whatever our quadratic. And two, we are going to factor out our common expression. These both have a 5x plus 1, so I bring out 5x plus 1. Also, we see that there's a leftover 3x and a leftover -2, and that provides us with our other factor. Well guys, here's the last thing that we are going to do. We are now going to set both of these equal to 0 to solve for x. So, in my nice purple, I can write 5x plus 1 is equal to 0, and in my nice blue, I can write 3x minus 2 is equal to 0. A little dividing line here. So, I know I will subtract 1 from both sides, and I'll have 5x is equal to -1. I divide both sides by 5, and I get my very first solution. Why don't I go ahead and write it up here, just in kind of like this nice little area up here on the top left. X is equal to -1 over 5 comma, and lastly, my other solution, I add 2 to both sides, and I get 3x is equal to 2. I divide both sides by 3, and we also get that x is equal to positive 2 over 3. Alright, guys, in a nutshell, that's one video showing you how to solve almost every single type of quadratic that we've talked about.